Good day. This is a PowerPoint that looks at how we count atoms. And in this case, it's trying to give a visual representation of different compounds so it's more relatable. So if you see a formula NaCl, you should have some idea that it would look something like this. Here's a sodium ion with a chloride ion, and we're representing the electrons would have transferred from the sodium to the chlorine. So this is 1 plus, 1 minus. But the counting atom point is, hey, 1 sodium, 1 chlorine. We've got to be able to count atoms for balancing equations. So you've got to know what formulas are telling you. Next piece, MgF2. Looks a bit like a bow tie. Well, you see 1 Mg, so that must be the Mg, and 2 Fs. Now I don't really care that there are 3 atoms. What I care about is that 1 Mg and 2 atoms of fluorine. That's what matters. We want to count element by element. Now, when you're balancing, you're going to use coefficients. And what you have to understand is that means you double everything that follows that particular coefficient. So if I used to have 1 Mg and 2 Fs, now I have 2 times 1 is 2 Mgs, and 2 times 2 is 4 fluorines. So we're going to illustrate that now. So when we say 2 MgF2s, there's one of them, there's the other. We see 1, 2, 2 Mgs, 1, 2, 3, 4, 2 times 2, 4 fluorines. May seem simple, but people often forget what coefficients mean. That's a problem. CuSO4, well, the capital letters tell us there's 3 elements, and it would look something like this, maybe a squash turtle. And so here's our Cu, here's our S, and there are the 4 oxygens. So you have to be able to quickly look at that and say 1 of those, 1 of those, 4 of those, just like it says right here. Now, here we have metal, complex ion, and we got 2 of these complex ions. So a lot going on here. And I tried to make the zinc color. And there's nitrogen, nitrogen, and 3 oxygens, 3 oxygens. So when I'm counting these, I have 1 atom of zinc. The 2 outside the brackets applies to what's inside the brackets. And so 2 times 1 is 2, 2 times 3 is 6. If you're going around counting, there are the 2 nitrogens, and then 1, 2, 3, 4, 5, 6 oxygens. Well, let's put a coefficient in front of that. How do we tackle that? Well, you leave that 3 until the end. You look at your zinc, and then you would triple at 3. You look at 2 nitrogens, multiply by 3, it's going to be 6. Then you go 3 times 2 is 6. 6 times 3 is 18. So your last step is to multiply by the coefficient. Visually, it's going to look like this. Now you could do it this way, where you just simply count, and you go 1, 2, 3 for the zincs, and you go 2, 4, 6 for the nitrogens, and you go 3, 6, 9, 12, 15, 18. But it's a lot easier if you know how to multiply these out. So there's our 3, our 6, and our 18.